Okay guys, we are working some more in section 8.5 today. So here we are, day 2. It is March 23rd. And we're going to start right here. If a line is parallel to a side of a triangle and intersects the other two sides, then it divides the sides proportionally. That sounds exactly like yesterday. Flip over to page 1 from yesterday. Go ahead, do it right now. Please flip the page over and notice that the first line is almost the same. If a line is parallel to a side of a triangle and intersects the other two sides, oh, this one doesn't have the word it in it, but pretty much the same beginning, just the conclusion part is different. Then it divides the sides proportionally. Yesterday, we said that you must separate the triangles. Today, so this side splitter, because we're splitting the sides of the triangle, and if we split these two sides, then there are a bunch of proportions we can say. This top part here, A, to the bottom part over on this side, B, is exactly the same as the top part on the right side, D, to the bottom part on the right side, E. That's one way. Or another proportion is we could say this top part, A, to the whole thing, C, equals, on the right side, the top part, D, to the whole thing, F. Or, there's one more even, and it's this bottom piece, B, to the whole side, C, equals, all right, what's the other side? Bottom piece, E, to the whole thing, F. Okay, so that's the today stuff. Rather than separating out the triangles, if you're working with the sides that got split, then you can set up all these proportions. Notice we did not use the parallels, the two parallel pieces. Okay, it's important to notice that these ratios only work for the two sides that got split by the parallels. The ratios do not work for the two parallel pieces themselves. When that happens, you must separate the triangles. And we will take, if that's a little bit fuzzy for you, we will take a look at some examples today where that'll happen, and you'll see what I'm talking about. All right, we start plugging on through some examples here. Here's the first one. We're going to solve for x here. The triangle is situated a little bit differently, but that's fine. Here's the two parallels. And so we're working with the sides that got split, this 12 and this 2, this 9 and this x. And we can set up this proportion, this piece 2 to 12, matches up with, on the other side that got split, x to 9. Simplify, 2 over 12 simplifies down to be 1 over 6. Cross multiply here, 6x equals 9. divide out that 6, simplify that fraction, and x is 3/2. And we were solving for x, so that's it right there. X is 3/2. Okay, moving on. Looking at this next page. Number 5. Number 5 here. All right, now, when we're solving for x on this one, we can't use this y or this 20. We can only use the sides that got split. So I can only use this 24 and this 8 with that 18 and that x. And we don't know what this piece is down here, so we really don't want to do 24 to 8 equals 18 to that much, because I don't know how much that is. But we could do this top piece, 24, to the whole thing, 24 to the whole thing, and that whole piece is 24 plus 8, 32. So 24 to 32 equals, on the right side, 18 to the whole thing, x. And then let's simplify this fraction. We can divide out by an 8, cross multiply, 3x equals 72. Divide out the 3, and x is 24. All right, that finds x. Oh, I think I forgot to put directions up here. I want you to solve for x and y. All right, it looks like solve for x and y, but it's solve for x and y. There we go, that's better. All right, now let's go through and solve for y. And notice that y is on one of the parallels, so we're going to have to separate out these triangles. We have the little triangle, and the big triangle. In the little triangle, that's 24, 18, and a y. In the big triangle, 32. Oh, and this whole side's x. Well, we just figured out that's 24. And then this bottom piece is 20. Now when we set up, and on this one, I would avoid this 24, just because if I made a mistake over here, then that's automatically wrong. So I tend to avoid that particular 24 over here, and I'm going to use the other numbers that we know that were given to us. So 24 to 32 is, and now this y piece, y to 20. Simplify again, 3/4. If you get the little shortcut here, 4 times 5 is 20. So 3 times 5, y is 15. Again, if that bothers you, cross multiply. 4y equals 60, and then y is 15. And we are done right there. X is 24, y is 15. Six. All right. I don't know that I can use side splitter on this one, because this side has a 3 and a y, and this side has an x and an 18. Both of the sides that got split contain a variable, so we're stuck in trying to set that one up. Let's go ahead and separate the triangles then, because we're going to have to use the parallels. All right, again, little triangle, big triangle. The little one's not quite the same shape, but close enough. All right, let's just transfer some measurements down. In the little triangle, I'm going to kind of cover up that extra piece there so I can see it. That's 12. That's y. Here's 18. And in the big triangle, this side is 16. This right side is a 3 plus a y. And this bottom piece, x plus an 18. All right, let's find y here. So, oh boy, we need a side here that matches up with a side over there that are just the numbers. Well, right here, 12 and 16. So let's set up 12 over 16 equals y over 3 plus y. Then let's simplify. We can divide out by a 4. 3/4. Cross multiply, and we'll have 4y equals 9 plus a 3y. Subtract that 3y. Y is 9. Good deal. Let's circle that in orange. All right, let's set up to find x now. Set up to find x. 12 to 16 is, all right, I need the x's. 18 over x plus 18. Cross multiply. Ooh, 4 times 18. Double it and then double again. So 18 doubled, 36. 36 doubled, 72. Multiply here, 3x plus, and then 3 times 18. 3 times 10 is 30. 3 times 8 is 24. So 54. Subtract that 54. Oh boy. 72 minus 54 is 18. So x is 6. And there we go. All right. Now, if this bothers you, if you're not sure when you separate the triangles or when you don't separate the triangles, separating the triangles will work every single time. It's a little bit harder to do if you're using the two sides, but it's absolutely doable. So if you're not sure when to use the side splitter, the piece to piece or piece to whole, or whether you should separate the triangles, just separate the triangles all the time. Works every single time on every side. All right, there's another related theorem to this. I kind of ran over in here with my work, but that's all right. It says if 3 or more parallel lines are cut by 2 transversals, so right here, I've got 3 parallel lines. Those lines are parallel. Here's the transversals. So if we have the 3 parallels or more cut by 2 transversals, then these parallel lines divide the transversals proportionally. This is very, very similar to the side splitter idea. It kind of compares pieces to the whole and piece over here, this top piece A to this bottom piece B. A to B is the same as the top piece over here, D to the bottom piece over here, E. Likewise, we can use this top piece A to the whole thing C, and this top piece D to this whole thing, oops, A to C, and then D, that piece to F. Got myself off track there for a minute, sorry about that. One more, bottom piece B to the whole thing C, and on the right side, bottom piece E to the whole thing F. Very similar to the side splitter with the triangles. Okay? All right, let's take a look at a problem on this. And here we are right here. I've got, oh, look at this, 4 parallels in this one. This piece is 7, this piece is 3, that piece is 4, and I want you to solve for x. You have no idea what these other little bits here are, but what we could do is see that this top piece 7 to that whole thing 14 has to match up with, on this side, x to the whole thing 56. Simplify, 7 over 14 is a half. Cross multiply if you'd like, or notice 2 times 28 is 56, so 1 times 28, x is 28. Again, if that's tough for you, cross multiply. 2x is 56, divide out the 2, and x is 28. We are good to go right there. All right, we have just a few more problems to take a look at today. I am here late at night and they are outside cleaning the hallway, so if you hear noise, that's what that is. All right, a few more examples, and these are not side splitter. They are not side splitter. You must separate the triangles. All right, try and keep these in the same orientation. So we got this little one up here. That's a 4, that's a 5. Follow the angle markings. Those are going to become important in this. There's your little triangle. Big triangle. So this is double, that's single. This right side in the big triangle is an x plus a 4. Right side, or left side in the big triangle is a 9. Okay. Now, the tough part in this is matching up the sides, because you want to do 5 to 9 and 4 to x plus 4. But look where this 5 is. This 5 is between a single arc and a nothing marked angle. So that 5 actually matches up with this x plus 4. So from the little triangle to the big one, the 5 matches up with an x plus 4, and this 4, which is between a double arc and a nothing, that 4 has to match up with the 9. All right, on this one we do have to cross multiply, and we'll get 45 equals 4x plus a 16. I'm going to come up here, subtract that 16. Let's see, 45 minus 15 is 30, minus 1 more, 29 is 4x. X is 29 divided by 4. That's it, right there. Okay, and you know this is not side splitter for 2 reasons. 1, I told you they weren't side splitter, and 2, clearly this side not parallel to this side, and I have no markings on there, so you cannot assume parallel. All right, let's take a look at this one. We have big triangle and little triangle. $70 degrees, an X, and a 4. Big triangle. All right. Now we're in a bit of a bind because I only have one pair of angles matching up. This one, I had two pair of matching angles, so I could kind of figure out how they matched up. But over here, I don't have that. I only have this 170 degree angle right here. However, if you notice, this angle right there is in both triangles. That angle is this angle in the little triangle, and it's this one in the big triangle. So now if we start to match stuff up, this X in the little triangle, that's between the 70 degrees and a dot. So that X has to match up with, between a 70 degrees and a dot, has to match up with that 7. On this little triangle, this 4 then has to match up with, between a dot and a nothing. Between a dot and a nothing, that has to match up with 3 plus X. Oh boy. I did not leave us enough space to do this, so I think we're going to have to come up here because I am going to run out of space very quickly. When we cross multiply, we have 28 equals, X times a 3 plus X. That's 3X plus an X squared. Well, maybe I can squeeze it in right down here. Oh, what are we doing? We have an X squared. Pull everything to the one side to make a 0, so I'm going to have an X squared plus a 3X minus a 28 equals 0. I moved everything to the right, and I just put the 0 on the other side. Factor. X minus 7, no, X plus 7, X minus 4. That'll give us X is negative 7. Or X is 4. Look back at the diagram. Can X be negative 7? Nope, can't be. So that one's out, which means X equals 4 is your solution. Yay. Wonderful algebra coming back. Oh, I did squeeze it in. Awesome. All right, thank you very much. Your assignment is 8.5 day 2. There is an 8.5 day 3, and that's tomorrow where we'll finish this up. But this is 8.5 day 2. Your homework for tomorrow is 8.5 day 2. Thanks. See ya. Bye.